Hello friends, we are studying complex numbers, and in the last lecture I introduced the concept of argand plane, what is an argand plane and how to represent a complex number on the argand plane. So we saw that the argand plane is very similar to Cartesian plane, okay, just a little bit of difference of notation. The real axis, the x-axis is known as the real axis, okay, if you remember, x-axis is the real axis and the y-axis is imaginary axis. Okay, any purely imaginary number is lies on the y-axis, and any pure real number lies on the x-axis. Okay, and we also saw that it is very similar to um, vectors. So if you want to add two complex numbers, it's very similar to how we add vectors. Similarly, if you want to subtract complex number, it's similar to vectors. In this lecture, we'll be talking about some basic algebra regarding complex number. Okay, so algebraic operations. So in the previous lecture, I told you that I represents iota. Okay, and it is nothing but under root of -1. So let's start. What will be I square? Squaring both sides, we'll get -1. So we also write it like this, that I square plus 1 is equal to 0. Okay, so I square is -1. If I ask you what will be I cube, so this will be nothing but I square into I, and I square is -1, -1 into I, so this is minus I. If I ask you what will be I to the power 4, so it is nothing but I square into I square. So -1 into -1, which is 1. So I to the power 4 is equal to 1. If you are going to repeat this operation, if I ask you what will be I to the power 5, I to the power 5 will be I to the power 4 into I, so 1 into I, so it is I. Similarly, I to the power 6 will be I to the power 5 into I, so I into I, which is I square, which is -1. Okay, so on and so forth. So we can generalize that I to the power 4n is equal to 1. Okay, when n is a natural number. When n is a natural number. So I to the power 4n is 1. What will be I to the power 4n plus 1? This will be I. I to the power 4n plus 2 will be I square. And I to the power 4n plus 3 will be I cube. So you can understand it like this also. I to the power 4n plus 1 will be nothing but I to the power 4n into I, and I to the power 4n is equal to 1. So 1 into I, which is I, and so on and so forth. Okay, so this is the general expression. I square is -1. So I to the power 4n plus 2 is equal to -1. I to the power 4n plus 3 is equal to I cube, which is nothing but I square into I, so minus I. So let me write it more clearly. I to the power 4n is equal to 1. I to the power 4n plus 1 is equal to I to the power 4n plus 2 is equal to -1. I to the power 4n plus 3 is equal to -I. So this is the first piece of information. So you can use it in many ways. Sometimes the questions are like this: I to the power 58 plus I to the power 60 will be how much? Okay, so I can write it I to the power 56 plus 2 plus I to the power 60. I to the power 56 is, I have written it in this form because 56 is a multiple of 4. Okay, so this will be I to the power 4n, which is 1. So this will be -1 plus I to the power 60 will be 1. Okay, this is of the form 4n, so this is 0. So the total answer is 0. So these are the type of questions that are generally asked. Okay, Okay, so next is the addition of complex number. So suppose there is a complex number z1 given by a1 plus ib1, and there is another complex number z2 given by a2 plus ib2. So z1 plus z2 will be, if you remember vectors, in vector the x component is always added with the x component, and the y component is added with the others component. Okay, so similar to the vectors in complex number also, the real part is added to the real part and the complex part is added to the complex part. So z1 plus z2 will be a1 plus a2 plus I times b1 plus b2, and you can extend this to any number of complex numbers. Z1 plus z2 plus zn will be equal to a1 plus a2 plus an plus I times b1 plus b2 plus bn. Okay, and addition is nothing but subtraction is nothing but a form of addition. So if you talk about subtraction, so z1 minus z2 will be nothing but a1 plus ib1 minus a2 plus ib2. Okay, so this will be a1 minus a2 plus I common b1 minus b2. Okay, so addition and subtraction is very similar. What about multiplication? Multiplication is also easy. So suppose z1 is equal to a1 plus ib1, z2 is equal to a2 plus ib2. Then z1 into z2 will be a1 plus ib1 into a2 plus ib2, and the normal way of multiplication will take place. Okay, so first you multiply a1 with each of the components of z2, and then you multiply b1 ib1 with each of the component of z2. So it will be, I can distribute like this: a1 into a2 plus ib2 plus ib1 into a2 plus ib2. Okay, I've distributed. Again distributing a1 a2 plus I times a1 b2 plus this will be I b1 a2 plus I into I is I square, which is nothing but minus 1. So minus b1 b2. So this total expression becomes a1 a2 minus b1 b2 plus I is common, a1 b2 plus a2 b1. Okay, so we follow the same method. You multiply each component with individual components. Okay, and as far division is concerned, z1 by z2, this will be given by a1 plus I b1 upon a2 plus I b2. Okay, so this is the basic idea of multiplication, addition, subtraction. Okay, then there is something called rationalization of complex number. Rationalization of complex number. Okay, so rationalization basically means you try to split the complex number into real and imaginary part. Okay, suppose you have a complex number a plus ib upon c plus id. Now if you look at this complex number, you cannot split this complex number into real and imaginary part. If you write it like this, a upon c plus id plus ib upon c plus id, Now this component again has imaginary part attached to it, and this component obviously has imaginary part. So we have not been able to separate the real and imaginary part. So rationalization helps us to separate the real and imaginary part. How do we do rationalization?